Okay, folks, it is that time. So today we have one goal, and that is we're going to work through the name, going from the name of an ionic compound into its formula, which is the easier of the two things to do. It's still difficult because if you don't know how to name the ions, oh yeah, that thing. If you don't know the names of the ions and what they translate to into the formulas, then it's still going to be difficult. But it is the easier of the two pieces. So I am simply going to describe. So basically what we do is we translate the name of the cation into its formula. We translate the name of the anion or the anion into its formula. Then we
cross, drop, and simplify.
Yes.
If you're together, would it always be a county?
Yes, it will always be a cation and an anion. Because think about it from a magnet perspective. If I have a cation, it's like having a positive end of a magnet, and an anion is like having a negative end. They automatically, if you let them go, snap together. But if you were to put two negatives close together, what do? They push away. And the same thing goes with our ionic compounds. So yes, we want to make sure that we always have a cation and an anion.
Other questions? So let's just start out straightforward. Let's start out with barium, chloride. You'll need your periodic table or be prepared to look at the one on the wall for now. Barium is a group 2 metal. So what's its charge? +2. The ending IDE tells me that I'm dealing with an element typically. So we're dealing with the element of chlorine. Chlorine is in group 17. The last or in group 17, what's its charge? -1. So you've translated the cation, you translated the anion. Now we cross, drop, and simplify. So we're going to drop a 2 onto the chlorine. And because it's not shown, it means we drop a 1 onto the barium. So the formula will have 1 barium and it'll have 2 chlorines. And that is the formula for barium chloride. Let's look at another example. Manganese, 3 peroxide. If the numerical value is showing, that means I am telling you what the charge is. So on our manganese, it's a 3+ charge. Peroxide is one of the polyatomics you have to know. And it is O2, 2-. Now that I have the formulas of the cation and the anion, I am going to cross and drop and then simplify if available. In this case, I'm going to drop a 2 onto the manganese, and on the peroxide, I need to drop a 3 because I'm dropping a number greater than 1. on a polyatomic, the polyatomic goes in parentheses with the number as a subscript outside the parentheses. So what I'm gonna do is I'm gonna give you several to work on, and Luna Bear and I will walk around answering questions. You can work in groups and all of that jazz, because to be quite honest, folks, that is all there is to taking the name of a ionic compound and getting it into its formula. So let's see. Let's walk around.
Okay, now use a PS.
I think it was the time.
Mm-hmm.
So how did you get it since it's like,
How did I get what?
like it's in, titanium's like in the middle of these, like transition levels, like.
Okay,
I
so
remember you saying something like about that yesterday.
I have to give you the numbers.
Okay.
Either that or I have to tell you the charge. Or you have to we'll talk about how you would get that Roman numeral from the formula on Friday. But basically, the information provided will always, in some shape, form, or fashion, tell you what charge it is on those transition metals. In this case, I just had to give it to you.
Does that answer your question? Okay. Other questions about the answers that I've got on the board? And where they came from? How I knew what?
So. So it don't matter if the charge is positive or negative, you still, if you cross it and drop it, it's gonna be the same number regardless. If it's a -3, it's gonna be +3.
It's just correct. It's always going to be just a number by the time you drop it. We don't drop the actual charge, in other words, which is the positive or the negative. We're just dropping the value associated with the charge. Other questions?
Yeah, no question.
Okay,
So in the, as far as the parentheses go, those are only for polyatomic.
that is correct. You only have to do it for polyatomics and only if you need more than one of them. So I say that because if you look down here at, perchlorate, I only needed one, so I didn't put the perchlorate in parentheses.
And is that the same, the phosphide? Well, not.
The phosphide, so it's only for polyatomics and only if you need more than one. Let me give you some more to work. Brr. This pen is not wanting to do something. There we go, finally.
Are the only three IMDs that are not done. For the most part, the ATE and the ITE tell you it's polyatomic. Well, always the ATE and ITE. There are three IDEs that are polyatomic. But all the rest of them are elements. The 3 IDEs that are polyatomic are hydroxide, cyanide, and peroxide. So these 3 are the only 3 IDEs These 3 are the only IDE that is not an element. Otherwise, if it's 8 or I, it definitely is a polyatomic. And these 3 IDEs are polyatomics.
So, the silver chloride, how come it's just AgCl and not AgCl?
Because silver is Ag and it's always a +1 charge. It is, it's at the very bottom of it, and there's only one element in that portion of the stair, and it's a +1.
It's the only one.
And that, so. Basically, it's all about how many elements are in each step. So this is a +1, these are a +2, and all these are a +3, because that's how many elements are in each step.
Does nitrite not have like a negative recharge? Does that change the stock?
Nitrite is in period 2. Period 2 does not, its charge does not match that of the element for the polyatomics. Other questions? You're seeing how critical it is to know your ions.
Yeah, for the volume,
The molybdenum,
yeah, winter.
okay, so this, I actually was kind of waiting for somebody to ask me that. So So molybdenum is 6 plus and oxide is 2 minus. When we took those numbers and we crossed and dropped them, you get MO2O6. But you can't forget the last word in the cross drop. And that last word is simplify. Both of these are divisible by 2, and so I did so in order to get MOO3. Yes,
So if that was like, for example, if it was on the test, you gonna take the simplified answer.
I will only take the simplified answer. Because I can't, ionic compounds, the formula must always be the lowest whole number ratio possible. Yes,
How did you get the bottom?
bottom left. So cesium is a +1. Hydrogen phosphate is HPO4 2 minus. In other words, the entire piece here is the anion. And so it's HPO4 2 minus. You cross and drop, and that's how you get these, the CS2 HPO4. Couple more, and then we'll call it a day. Ammonium, by the way, is one of the only two cations that are polyatomics. What now? It's the same thing. I think I heard you. It just took me a minute to register. Ammonium is NH4 plus 1. Nitrate is NO3 minus 1. Okay. Questions? Keep working on memorizing those ions, folks. As you see, it is critical. You're not going to have your material. It's either going to be you have your stuff to look at on the test, and the test is longer than I would make it, or vice versa. Basically, you've got to know what you're doing. They're both a +1. So cross drop, and anytime you're dropping a 1 onto a there it goes. A 1, it does not show up. So it's just you put them together. Because the 4 and the 3 are part of the polyatomic themselves, so you don't do anything to them. I will stay and answer questions, but if you're good, you're free to go. There is homework. There's 12 problems, I think, over this stuff. It's already posted. I'm trying to get better at it this week.
Is it, can I come in next Monday to talk about my test?
Sure. You mean the polyatomic version of where it's in a periodic table?
Yes,
I do upstairs, yes.
okay.
It's also posted on your Blackboard in last week's folder, I believe.
Thank you. Am I gonna get my exam?
Really? No. Hey. Wrong folder. Other class.
I have a question on the potassium nitrate limit.
Yes,
Question how we.
nitrite,
Yeah, nitrite.
okay,
I wrote nitrate, that's one.
okay.
I have a question for, I think we already went over actually. Hope I'm remembering. Selenium, oh no, cesium and.
Cesium
Yes.
And hydrogen phosphate? Okay,
Yeah,
let
how
me,
does the, how does, isn't it a charge of -3? And like, how did-
phosphate is a -3. So let me erase this. So what you're thinking about, I think, is PO4 is a 3-.
Yes.
However, once you add a hydrogen,
Oh,
the
It's a-
charge drops to 2-.
because it's a charge of the hydrogen.
Correct.
That's what. Thank you.
Not a problem.
I have a question. The nitrate, I keep, what's in the group that has like a -3.
Nitrogen is, but because of it being in period 2, nitrate and nitrite only have a -1 charge.
Okay.
So it's period 2 that screws it up when you get into the polyatomics.
I also got another question, like, on the metals, like for the charger, like how you supposed to like, if they're not like shown, like, how you supposed to like, know? Like-
Group
like
1,
so-
group 1's always a +1, group 2 is always a +2.
No, I mean like from like 3 to 12, 3 to 12.
So starting with 3 to 12, those will, other than silver, zinc, cadmium.
Let me get up here.
So it's like zinc, is it always?
This one's always a +1.
Copper?
This one and this one are a +2. This one and this one and this one are a +3. They form a stair step.
Like the stick, yeah.
Zinc is in the +2 one, so it's always a +2.
Zinc is always a +2,
Yes.
and silver is always +1.
Silver's always a +1. Zinc and cadmium are always +2. And these 3 are always +3.
Is it because like nitrite and nitrate is followed by oxygen?
That makes them polyatomic. It has to do actually with their structure, which we are not getting into as to really why it has the negative charge it does.
And
And why it's odd.
Is the subscript 2 then?
For nitrite, it is, but nitrate is a 3.